This quick video is going to show you how to analyze and extract your radio data. Start out with the Skynet Observatory page, go to Radio Observing. You'll see a list of all of my data sets. The two DAISY patterns that I've run, I will show them to you. They're not the best. So the first thing you need to do is go to the Green Bank website. That's where all of your data is stored. Here is my radio image of M88. There's a problem here. As you can see, my 3D map has got the object showing up in high radio in only one of the lobes. So my DAISY pattern was not centered on M88. It was not centered on the target. And that also shows up here in the FITS images. You're used to these FITS images from your visual optical observations. With radio, you get 2 for the price of 1 because you've got your left and your right channel. And we could combine these into representational color images. We would have to open them up just like you do for your opticals. But you can see that our radio loud source is sitting out here on one of the lobes. So this is a bad data set because of it. But to look at the raw data, simply click on the calibrated button here or the raw button. The values will be different. So I like to use the calibrated values. The first column is our time. The second through the fourth column are location. So red ascension, declination, azimuth, and elevation of the radio telescope. And here's our left and our right channel data. Starts out not calibrated, then the calibration kicks in. That's what the 1 value shows us. Then we get back to the 0. So calibration is off. So now we are looking for a change in that background data. Is there a radio source out there somewhere? Got lots of 1s and 2s. And then when you come to a high value, that's when the calibration kicked back on again. So we really didn't find a high radio source. There are a couple of 3 values here. The 2s are showing us there's something there. But again, because our telescope wasn't centered properly, that's a bad data set to work with. Unfortunately, my other DAISY, right here, D404, also was not centered well. Well, here the DAISY became a circle. I don't know what happened there. So what I'm going to show you is my M88 map. So this is what a map looks like. A map takes a lot of observation time to complete because what the scope is doing is it's scanning back and forth, back and forth, back and forth over a rectangular area that you request. So here is my Radio Loud M88 as a 3-dimensional map with radio data and as FITS files. And here you can see the object was Radio Loud over here through the scans, and then it got quieter and quieter. So the scan started here and went across to the other side. So now I can look at the data, get past the calibrations material here, and look where was it the most radio loud. We've got 19s and 20s, and then it drops off, and then it picks up again, and it drops off. Then it picks up again up to 26s. So we're looking for our peaks. What were the highest values that it recorded? 26.93. So if you're doing a map, you've got a lot of data to work with, and I would recommend downloading this file into an Excel document so you can actually search for the maxes and minimums. But if you're just working with the DAISY image, which is what I want you to do this first round, it's easy to just eyeball and compare the values because you won't have as much data.